as a weight. What that was doing is that using that tool, it was measuring from line of sight up or line of sight down. And it was giving us a degree. And those were the degrees whether it was an elevation or a depression. And one of the things is that if you are angle of elevation, obviously, it is what we call line of sight up. Okay. Whereas angle of depression would be line of sight down. Now, one of the things that you'll see is that if you're talking about this whole idea of line of sight, aren't line of sights parallel? Sure looks like that. Which means your elevation angles and your depression angles will always be da, da, da. Now, last year you may not have used a whole bunch of depression problems where you had to switch inside of an angle and move things around and whatnot. It wasn't as common to get that complicated, but this year we'll try and make a couple extra problems here or there for you. It's really, really pretty painless to work with these types of problems. It's a matter of really just kind of drawing a picture. And when we're dealing with trig stuff, it's just a relative idea of what you're actually looking at. Let's see if I have an example here. There it is. And we'll talk about it. Yeah, story of my life. Probably. Good chance. PDF file, and I usually just assign the problem, but over the course of going through this problem a lot of times, it's easier to help explain it and how to understand what problems like this are talking about. Now, I know this is a lot of words here, and I apologize. We had a department meeting this morning. I didn't get a chance to make a copy of this. This is on the PDF of 13.1. But what it's saying here is that you're in a helicopter, yay, and you're a surveyor in a helicopter, and you're trying to determine the width of an island, illustrated at the right. Why not?
Someone's got to do it.
You've seen those people that are out there with the tripods and the staff of rock.
I don't know how they're doing it on a helicopter.
Really? You've never seen the guy that's standing here?
Yeah, one of them has like a weird lens.
And he's looking through this machine. And there's another guy here.
Where are
The survey crews.
To make sure it's level.
What they're doing, what they use surveying equipment for a lot of times is you know how roads deteriorate? All right, First Street sucks. First Street's awful. It's terrible. But what they do a lot of times with surveying equipment is they're looking at have the roads sunk in certain spots and things like that because they know where their data points are. A lot of times you'll see spray paint markers on the roads and stuff like little X spots and whatnot. Those are going to be measured distances, and what they're doing is they're measuring the angles of like what the elevation and depression is between those two zones. So what they're being able to determine is from their, I don't want to say not like their standard set, but their initial markings, their initial findings, if you will. If over 1,000 feet, the road pitched a degree. I don't know, I'm making that up. I don't know if that's right or wrong. But if the road pitched a degree over 1,000 feet, but then like 2 years later it pitched 3 degrees, that means that a certain part of the road is sunk. So you might have to do some worrying about, what's going on. Is there been cracks and things like that? They use surveying equipment. I know this I've seen this when they dig foundations for houses. I don't know the last time you guys saw a house foundation get dug, but yeah, they're a lot of them because what they do now is they go out there with basically GPS markers, and they go out there and they tag certain spots on the ground, and then on the big diggers themselves are just lasers, and they know computerized where to go out to, how far over to go, dig it down. It's so many feet. That's how they know how to do this stuff nowadays. It's insane. It's all computerized. It's kind of the same idea. Yes, a helicopter is not the most efficient thing in the world. Nowadays, you can take a rangefinder with a laser beam, and it does it right there. You really don't. You could use a drone, which you probably could. And that's the idea. More and more of these things are becoming more automated because of lasers, because of things. I hear they decay at a specific rate. Anyway, so what's happening here is they're giving you a bunch of information. They know that you have 2 separate angles of depression. Okay. Now, if you have 2 separate angles of depression, that means you have 2 separate angles of elevation. Okay. So what you're looking at here is that you're going to be able to determine via 2 separate triangles that overall distance. You do that once for the 39 degree. Let's see here, we have a triangle with 39 something and 3,000. Then we do that again with 27 something and 3,000. Now, those 2 distances will be different. If I subtract the smaller distance from the larger distance, what then do you wind up getting? You get the width of the actual island. Yes, if I subtract 27 from 39, I do get 12. That is very correct. But I'm talking about the distance. So you weren't wrong with your subtraction. You were just doing the wrong subtraction. So you gave me the right wrong answer. Good job. Partial crush, right? So when we trig it, in this case we have tangent for both of them, if I'm not mistaken. Make sure I am in degree mode. The pattern is full. 39, tangent 39 thirds, so it'll be 3,000 divided by tangent of 39. I'm getting 3704.69. And I get 588, 5887.83. So I take 5887.83, subtract 3704.69. And I'm getting an overall width of said island. You guys okay with that? I don't know if we ever did one that had that many steps last year in geometry, but that's kind of like as complicated as a lot of these elevation depression style problems do get in Algebra 2. And don't get me wrong, I can come up with some really crazy problems for you if you want. I have no problem doing that. I do. So, let's see here. What was the other one that was on this one? Oh, that's that picture of Fontana that I was trying to get him to, what do you call it? With the kiss and pick thing, which obviously didn't work. So, who's winning? Oh, she is. We were curious who's winning. We were talking about this morning. So, bless you. What number is this? 43. This is what 43, 40. On the 13.1 PDF. On the 13.1 PDF. Do the elevation depression problems 43 through 50. Yeah. I just didn't want to try and cram all that into one day. We could have, but there's no reason. If you're not here tomorrow, we are going to start law of sines, which is something you did see last year. I don't think we'll do the ambiguous case tomorrow, to be honest with you. I think we're just going to do the standardized, this is the law of sines, that we remember how to set up and solve. We'll play, we may or may not get to the ambiguous. I'm not quite sure how far. Do you know the ambiguous? How are you setting it up?
I found these first.
That should work too. I know that I also posted the worksheet with angles of elevation, depression. I don't think we need to do any of these. These are pretty easy. Yeah, these are really easy. I'd rather have you guys do ones you can't draw pictures of. So that was just in case we needed more. So, yeah, I just did.
Oh my gosh. I want to.
So, you don't have a drill book, I'll at least put this here so you can restart. Keep the scroll on this thing. Yeah, scroll here.
No.
I didn't do that. Nobody saw that. Stop laughing, Reese. You guys ever rode an incline train?